Hi Kayla, it's Mr. Ng. Trying to help you out with these little naming rules. Hopefully we could get you up to speed for your test on Friday. These are not the problems that you sent me. Instead, these are problems that I've kind of altered. I changed the names of almost all of these things. That way, you can still get some practice as you try to solve these on your own. And the thing is, looking at these things, they're very diverse. They're not all going to have the same rules because some of these are ionic and others of these are covalent. And these two types of compounds have distinctly different naming rules. So the first thing you got to do is you got to figure out, is it ionic or is it covalent? The easiest way to do that is to look at the first word, and you got to notice if it's a metal or a non-metal. All the ones that are metal are going to be ionic, basically, except for this ammonium. I'll talk about that later. And then all the ones that are non-metals will be covalently bonded. So again, if you don't remember, this part of the periodic table refers to all the metals, and this part refers to all the non-metals, basically. And then the guys in between are metalloids. So ammonium, that's not even on here, so don't even sweat it. I'll talk about that later. Carbon is over here. That's a nonmetal. So this thing is going to be covalent. Iron, sodium, aluminum, and calcium are all metals, right? So iron's over here, sodium's over here, calcium is over here, and aluminum is over here. So I know that the other guys are all starting with metals, so they're all ionic. So these things are starting with metals, right? Ionic, and the covalent ones start with nonmetals, right? So the easiest ones to name are the covalent ones. So let's move on to the covalent ones. And now that we've identified which one is the covalently bonded molecule, it's the carbon dioxide here, let me show you how to name that thing. So molecular formula. So I noticed that all of these are covalently bonded because they all start with nonmetals, carbon, sulfur, and silicon. These are all nonmetals. And these become really easy. Carbon dioxide, di means two. So one carbon and two oxides. Right? I know it ends in ide, but it's really referring to this oxygen. So carbon dioxide is just CO2. The two refers to how there's two oxygens, CO2, carbon dioxide, right? I know in chemistry it's a little weird. We put the number behind the letter, but don't let that fool you. Sulfur hexafluoride. Hexa refers to six, so I just have to write sulfur and six fluorides. Sulfur's right here, fluoride's right here, S and F. So this thing becomes F6. Pretty easy, right? And then finally, silicon monoxide, one oxide. Silicon is right here, right? Silicon monoxide is just one O, silicon monoxide. Done. So these guys, the covalent ones, are really easy to find because, well, all you got to do is know your prefixes. Mono means one, di means two, tri means three, right? Tetra means four, right? Those are simple rules. So the only trick there is you got to figure out which ones are covalently bonded, which ones are going to use these rules. And the easiest way, again, is to spot if it starts with a metal or a non-metal. If it starts with a metal, if it starts with a non-metal, then we know they're molecules. They're going to be covalently bonded. And then we do the rules where they have the little, the little, put the letter and then how many of the other letter, right? You use a little number thing, all right? And another way to spot this, if you see dis and tetras and things like that, they're going to be covalently bonded. So you could just use this rule, okay? So let's go back to that list. Again, this is the list that you gave me, or kind of, and we just did carbon dioxide. That was covalently bonded, and we're done with it. So long, right? But now we got ammonium carbonate, iron sulfide, sodium nitrate, calcium hydroxide, aluminum nitrite. So now the next step is, well, we know that all of the rest of these are going to be ionic compounds, but some of them are from polyatomic ions and others are just from simple ions. And how do you figure that out? Well, you look back here. If it's an 8, it's complicated. Get out of here. Here's an 8. Get out of here. Right. Here's an 8. Get out of here. These are all complicated polyatomic ions. And here we have a hydroxide. Hydroxide, that's not a thing. There's no, right? That's not a hydrogen, by the way. A hydroxide is an OH minus. So this is actually a complicated one. The only one that we have left that's a simple ionic compound is iron 2 sulfide. And this formula is pretty easy to do. Iron 2, iron's right here, and it's iron 2, so we know that it's Fe 2 plus. How do we know it's 2 plus? It freaking tells you, right? We know that all metals become positive ions. They all become cations, right? And a sulfide is right here, and sulfur is right here. What's the charge of a sulfide? Well, the periodic table is organized pretty easily. So all the alkaline metals, all of these guys, right? They make 1 plus ion. All of these guys make 2 plus. Aluminum over here makes 3 plus. See how there's a little pattern? Just skip all these suckers, right? For the transition metals, we just rely on the Roman numeral, right? The problem will tell you. It makes it really easy. And then all these guys are no longer pluses. These are 1 minus. These are 2 minus. These are 3 minus. And here we're talking about a sulfide. So we know it's S2 minus. So iron, the ion for iron is F2 plus. The ion for sulfide is S2 minus. Hey, they cancel each other out. And when you write them together, because they cancel out, you just write FeS. Done. That is the formula for iron 2 sulfide. Now let's do some more examples. So I got some more. Copper 2 chloride. Well, this becomes pretty easy. Again, we're going to do that thing where we try to do the plus side and the minus side and try to get them to match together. Copper 2 is Cu2 plus, because I know that copper is Cu. It's right here, copper. And 2 refers to 2 plus, so I'm done. Chloride. Chloride is right here on the periodic table. If you remember, this column is all 1 minus, so this is Cl minus. Uh-oh, these two don't cancel out. If they don't cancel out, you try to figure out a way in which they do cancel out. So if I have 1 carbon and 2 of these chlorides, they will cancel out, right? Does that make sense, right? Cu2 plus and then Cl minus with another Cl minus. That's 2 minuses, it'll cancel out. But we're kind of cramming, so I'm going to teach you a much simpler trick. You do the old switcheroo. You put that sucker here, you put that sucker there, meaning if I was gonna, this is kind of a mess. If I was gonna rewrite it, I would do, it starts with Cu2 plus and a Cl1 minus. I'm gonna move you over here. I'm gonna move you over there. That means it's gonna be Cu1. I'm not gonna write the 1, and then Cl2. CuCl2. So you're just gonna move that sucker there because it takes 2 of these chlorides to cancel out this 1, 2 plus copper, right? 2 pluses, and then each of these I have only 1 minus, but 2 of them added together becomes 2 minus. They finally cancel out. Hence the formula CuCl2, copper chloride. Magnesium oxide. Magnesium is right here. If you remember, these are all 2 plus. So magnesium is going to be Mg2 plus. Oxide is right here. All of these guys are going to be 2 minus, right? 1 minus, 2 minus, 3 minus, right? So oxide is O2 minus. Hey, they cancel out. So easy. So the formula is MgO, magnesium oxide. Finally, aluminum sulfide. Aluminum is right here. I don't know if you remember, but everything in this column will make a 3 plus ion. So this becomes Al3 plus. Sulfide is right here. Sulfide, that's a 2 minus. S2 minus. They don't cancel out. So we do the old crisscross applesauce. This becomes Al2, S3. This is the formula for aluminum sulfide. Good? So we covered how to do the covalent ones. Look for the ones that start with nonmetals, and then just do the prefixes. Carbon monoxide, CO, right? One oxygen, right? And then for the simple ionic ones, just do that crisscross applesauce thing. Well, the first thing you got to do is you got to figure out what ions they make, right? And that's pretty easy because you can either go through the periodic table and just know that, all of 1A is 1 plus, all of 2A is 2 plus, 3A is 3 plus, 5A is 3 minus, 6A is 2 minus, 7A is 1 minus, right? Well, it's kind of a mess. Oh, sorry. And then for this last one, so I talked about how to do the simple ones. That's this guy. I talked about how to do the covalent ones. That's this guy. The rest of these are all polyatomic ions, which in many ways are a lot easier because all you got to do is look them up. The problem is, like, how do you recognize if it's a polyatomic ion? So you do it by, number one, having it start with a metal, and then having it end with something that's not on the periodic table. So unless you've been doing a lot of chemistry, you might not be able to tell what's on the periodic table. The ones in the periodic table are typically the ones that end in ide, I-D-E, except for this guy, hydroxide. The one exception, hydroxide, is OH minus. So for all the rest of these, you just have to look them up in a table. Ammonium carbonate, calcium hydroxide, aluminum nitrite, and sodium nitrate. You have to use one of these here tables, okay? Let's do the first one. Ammonium carbonate. Ammonium is NH+. Ammonium, right here. It's the one cation that is polyatomic. So I'm going to write NH4+. And a carbonate is over here. Let's look for a carbonate. Here's a carbonate. Carbonate is CO3 2 minus. CO3 2 minus. So I have a 1 plus over here, a 2 minus over here. That's not going to fly. Let's do that crisscross applesauce thing. Let's put this over here, put that over there. That means there's going to be 2 ammoniums. So I'm going to write it like this, NH4. We treat the NH4, that ammonium, like it's its own thing, and now there's 2 of them. And then the carbonate, CO3, because it's only one, I don't have to do any sort of funky things. Good. So sometimes people will write it with a little bracket like this, NH4, 2, oops, bracket, and then CO3. This is ammonium carbonate. Okay, let's do a couple of more. So we did ammonium carbonate. We know this one is covalent. We know this one is a simple ionic one. Sodium nitrate. Sodium is Na+. I knew that because it's in group 1A. Nitrate is right here. NO3 minus. NO3 minus. 1 minus, 1 plus. That cancels out. This becomes NaNO3. Calcium hydroxide. Where is this calcium? Oh, calcium has a Ca2+. You find that through the periodic table. It's in group 2A. Hydroxide is OH minus. 2 plus, 1 minus. That doesn't cancel out. So we do crisscross applesauce. Put that there. This becomes CaOH. 2. See that, how I put in a little parentheses to show that there's 2 hydroxides. If you don't put the parentheses and you put CaOH2, it looks like there's like 2 hydrogens and only 1 oxygen, and that's wrong. So don't do that. I'm done with this one. Cool. Finally, aluminum nitrite. Aluminum, I know, has the charge of Al3+, right? That's the aluminum ion. A nitrite is right over here. Here's a nitrite. Looking at my old list, NO3, NO2 minus, 3 plus, 1 minus. That does not cancel out. So I'm going to do the old crisscross applesauce. This becomes AL, NO2, 3. This is the formula for aluminum nitrite. So, in conclusion, I hope that helps. Number one, figure out if it's ionic or covalent. Is it covalent? Does it start with a non-metal? Right? If it does, then, do the thing where you use the prefixes, right? Carbon dioxide is CO2, right? Dioxide, right? That becomes easy. Number two, figure out, is it a simple ionic compound or is it polyatomic? If it's polyatomic, just look it up in a chart. Use the chart. If it's simple, then use the periodic table. And then you got to do the old crisscross applesauce to make sure that the numbers match up. And there you go. I hope that helps. I know it was a lot at once, so feel free to kind of look over certain sections over and over again. Or if you get back to me by, I don't know, by maybe like 9:30 or so, I could probably help you out with yet another video. And good luck on your test. Bye.